Good morning, kiddos. Hope y'all are having a great day. We are moving on to our next unit in Algebra 2 today. So our next unit, we're still working with quadratics like we did last unit. It's just kind of a continuation of that. So our first learning target is I will learn how to solve quadratics using factoring. So we spent the couple days in our last unit learning how to factor, and we're doing that today, and we're just adding one step onto it. So we can go ahead and title our notes Solving by Factoring. So since this is just a continuation of the skills that we already learned, we're just doing one extra simple step today. This is a one-day learning target, ideally, at least when I'm making this video, it's a one-day learning target. So make sure you're doing your notes and your practice today. So we'll do a couple examples together, and then I'll give you 2 examples to try on your own before you head into practice on Delta Math. So our first example is we're going to have x squared plus 4x plus 5 equals negative 6x plus 5. So we know that we're going to be factoring. So remember, when we're factoring, we're breaking stuff down. We're taking stuff in a more complicated form and breaking it down to a simpler form. But before you factor, everything has to always be set equal to 0. So we're going to have to move this over. So we're going to add 6x and subtract 5. So we'll add 6x and we'll subtract 5. And we're going to have x squared plus 10x equals 0. So then, once we have it set equal to 0, we're going to have to determine, well, what kind of factoring can I do? So I have 2 terms. So we learned that we're either going to have to do difference of squares or greatest common factor, because we can't do any of the trinomial or the grouping ones unless we have 3 or 4. So these both aren't perfect squares, so we're going to have to do GCF factoring. So GCF, greatest common factor, what's the biggest thing that I can pull out? So this one has 2 x's, this one has 1. I can pull out 1x, and then that's all I can pull out, and then whatever is left over. So x squared divided by x is x. 10x divided by x is going to give me a plus 10 equals 0. So we have this factored, and this is what we learned how to do last unit. Now we're going to take it one step further, and we're going to solve. So we're going to figure out what solutions, what values of x make this statement true or this statement true, same thing. So the way you do that is by taking advantage of the multiplication 0 rule. I'm blanking on what the mathematical term is at the moment. But essentially, if 2 things multiplied together equal 0, that means that themselves, one of them has to be 0, if that makes sense. Or one of them has to give you 0. So like whatever you plug in for x here, it's going to give you 0. So essentially what that means is you're just going to have to take up every part that you have and set it equal to 0. So your first part is just going to be x, set that equal to 0. Your second part is what's inside, so x plus 10 equals 0. And then you're going to solve, so you're going to get x by itself. So because our value is squared, we talked about this last unit, if it's squared, that means you're going to have 2 answers. So this one's already solved, so x equals 0 is an answer. And then we have to get x by itself, so x equals negative 10. And this would be your other answer. So the only thing different with this unit, with this learning target, is you're taking it one step further and setting those factors equal to 0 and solving. So these are called factors. And these are called solutions. I teach factoring a lot in my senior math class, and a lot of times we get factors and solutions confused. So please make sure that you know that factors is when it's set equal to 0. Solutions are when you solve for x. Okay, so that's our first example. Let's do our second example. So we're going to have x squared plus 2x minus 57 equals x minus 1. Again, we're going to have to set that equal to 0, so we'll minus our x and we'll add our 1. So that's going to give us x squared plus x minus 56 equals 0. So now we have to determine what type of factoring to do. So we have 3, so odds are it's going to be one of our trinomials. 56 isn't a perfect square, so it's going to have to be our regular trinomial factoring. So we'll make our x and we'll say, okay, I have negative 56 up here and I have 1 down here. What are two things multiplied together to equal negative 56, but add together to equal 1? In this case, it's going to be negative 7 and 8. Negative 7 times 8 is negative 56. Negative 7 plus 8 is going to give us 1. So if you remember back to trinomial, we can rewrite that as x minus 7, x plus 8, and that's going to equal 0. And then you're going to set both of your parentheses equal to 0 and solve. So then x is going to equal 7, and x is going to equal negative 8. So these are the solutions that make this quadratic true. Or if you want to think about it in terms of graphing, it would cross the x-axis at 7 and negative 8. That's where our parabola would cross. All right, and then lastly, number 3, we're going to have 5x squared minus 7x plus 4 equals 6x plus 10. So we're going to subtract our stuff over, and that's going to leave us with 5x squared minus 13x minus 6. Excuse me, sorry. And that's going to equal 0. So for this one, I'm running out of room here. We have 3 terms. It's going to be one of our trinomials, but our a is not equal to 1. So we're either going to have to do the AC method or the perfect square method. 5 and 6, those aren't perfect squares, so we're going to have to do the AC method. So remember, this is the last one we learned. It's probably the lengthiest one. This is Miss Morgan's favorite one. So you're going to multiply your A and your C, so negative 30. And what are two things that multiply together to be negative 30, but add to be a negative 13? Let's see. We're going to have 10. Why is Miss Morgan blanking on her factors of 30? Let's see. We're going to have negative 10 and 3, but that's not going to give me negative 13. Miss Morgan is blanking at the moment. Let's see, look back at my notes here. So that would be negative 10 and 3, or negative 3 and 10, or we'd have 6 and 5, or negative 6 and 5. Okay, we're going to have to pause. How do I pause my recording? Oh. Okay, Miss Morgan figured it out. Sorry. Don't know why I was blanking. It's going to be negative 15 and 2. See, this method is kind of tricky because, or even factoring in general is pretty tricky because you have to remember all your multiplication tables. So negative 15 and times 2 is going to give me negative 30. Negative 15 plus 2 is going to give me that negative 13x. So then I have to rewrite that. So I'm going to plug those back in. 5x squared minus 15x plus 2x minus 6 equals 0. And then I'll have to do my factor by grouping. So I can pull out a 5x, leaving me with x minus 3. I can pull out a 2, leaving me with x minus 3. Then I'm able to rewrite this. I'm running out of room. We're going to have, this is going to give us 5x plus 2 and x minus 3. You have to set both of these equal to 0. So 5x plus 2 equal to 0 is going to give me x equals negative 2/5. X minus 3 equals 0 is going to give me 3. So set those equal to 0 and solve, and those are going to be your answers. Okay, I'm going to give you 2 more for you to try and check yourself. So for example, 4, I want you to try and do x squared minus 2x minus 4 equals negative 2x plus 5. And then for your 5th example, I want you to do 5x squared plus 10x minus 9 equals 3x minus 3. So I want you to try both of these independently. And for this one, you're going to have to do difference of squares as a hint. So difference of squares. And this one is going to be a C factoring. When you do this, you should get your answer for number 5 as x equals 3/5 and x equals negative 2. That's how you'll know if you got that one right. And then for this one, you should get x equals 3 and x equals negative 3. All right, those are your notes for today. Go ahead and hop in and do your practice. Let me know if you have any questions. Let Mr. Mason know if you have any questions. We're here to help. So hope you all have a great day, and I'll talk to you soon. Bye.